Next up, we have Dennis Duckworth with VoltDB.
Thank you. Boy, that was brilliant, Chris, having an animation take up half your presentation. I should have thought of that. 10 minutes. We just joined O'Reilly in taking over management of a program called Data Ignite in the Boston area. And there, the presentations are limited to 5 minutes, and they auto-advance every 15 seconds. So talk about a challenge. And if anyone's in the Boston area and wants to participate, we're always looking for participants in that. So just to get you started, to give you some background on VoltDB, VoltDB is a YASC. And if you don't know what YASC is, it's sort of like Yarn. It's yet another Stonebreaker company. It was started out of a paper called HStore, and Mike Stonebreaker and his academic team have had a really good success in following a certain template or process. They do some research into a particularly nagging data management problem. They do some academic work on it, write a paper, and then they form a company to actually offer a solution for that. So if you look at CStore was a paper that he did, and Vertica was the result of that to address OLAP and creating the columnar data format for really fast analytics. Then he took a look at the transactional side. And it's sort of like what the NoSQL guys did. They took a look, and what NoSQL did was basically threw out everything. They said, let's get rid of all the relational database stuff. Stonebreaker and his team said, not so fast. There's some really good things about relational databases that we want to keep. Let's see what we can throw away to try to streamline it, make it run a little bit faster. So they took a look at things like locks and latching, and they figured out ways of getting rid of that. And VoltDB was the result of that. So we're really fast for running transactions, and when we say transactions, we mean real transactions, real ACID compliance, full durability, full isolation, serialized isolation, concurrency, atomicity, and so forth. So, and if you look at some of the other things, some of the other solutions like NoSQL solutions, there are trade-offs with trying to achieve high performance. We achieve high performance with all of those constraints. And we have full integration with OLAP, Hadoop, data warehouses. We'll talk about that in a little while. So if you think operational or transactional workloads, that's where we fit in. And I heard Nikita talking about VoltDB a little bit yesterday during his session, and if you attended that, it was great to hear him talking about what VoltDB could do. There were a few misleading statements and so forth. He's talked about VoltDB being only SQL. Well, since we're a relational database, we do use SQL for accessing the data, but we have stored procedures in Java that, and we actually have C++ running for all our memory management and our SQL execution, so we don't have heap problems and garbage collection problems with VoltDB. We also have clients for things like C#, C++, Java, JDBC, Ruby, PHP, Python, and various others. And we even have a JSON interface. So even if you're using a programming language that I didn't mention, you can use JSON to be able to interface with VoltDB. So the use case I wanted to talk about, our innovation, is helping our customers to simplify their implementations. And we had one customer come to us and said, we love what Lambda does, but we need to change it a little bit. Because what we want to be able to do is have the speed layer be as accurate as possible. Okay, and one of the drawbacks of Lambda architecture is the speed layer is for speed, and you use your batch layer for the really accurate stuff, and that comes later on through that batch. So what we had proposed to them, and there are white papers and so forth that we offered that talk about this, is sort of a consolidation. So being able to put the speed layer and the batch layer in one layer, in effect, and have it be a stream. So all the data passes right through VoltDB as that speed layer where we can take action on the data as it's passing through, so request response type of thing, and it goes right into that batch layer, and then you can do further analytics on that and refine what is done in the actual speed layer. And we have lots of customers in the telco space using us for this type of thing, financial services, IoT, and so on. So the company that we were working with on this is MaxCDN. It's a content delivery network. And what they wanted to do was pretty simple. They wanted to do real-time billing for their customers. And if you're familiar with the content delivery network, they serve up lots of pages, and they get paid for the number of pages that they serve up for their customers. And they wanted the customers to be able to have a real-time access to their billing. So not overnight billing type of thing. They wanted real time during the day. And so what MaxCDN did was implemented VoltDB as part of this compressed Lambda architecture to be able to provide that functionality. And what their findings, and we had a webinar recently where the CTO talked about this. They loved the SQL interface, and they tried us against Trident and Spark Streaming, and we'll talk about that in a little bit. Merged the good things of old world transaction processing, SQL transactions with good things of new world like no locks and K-factors. And if you're familiar with Vertica, it's a similar kind of K-factor for high availability. Very simple, intuitive, fast query response, horizontal scalability. So all those things were perfect for MaxCDN's usage. They compared us with Triton along with Cassandra and HBase, and here are some of the comparisons that they made. And Bazad is the CTO there, and he's a raving fan. And you can see some of the comparisons here of the number of environments, very simplified. With the VoltDB, the atomicity, there was a difference. We could support multiple statements in the atomicity transaction. The number of back and forths that were required, index lookups, was substantially lower with VoltDB compared to the other solution, and much less transaction ID space was required, 12 kilobytes as opposed to 18 gigabytes for the combined solution. So kind of in summary of that, MaxCDN loved the simplified architecture. They were able to provide this real-time billing for their customers with 1/10 of the compute resources, and they were able to maintain 100% budget accuracy, eliminating dollars and so forth. And it turns out that basically what this comes down to is counting. And counting turns out to be very difficult in a distributed environment. I read recently about this joke press release that DataStax put out about Cassandra, announcing the 1 millionth download, but also the 999,995 and 1,027 based on whichever node that was reporting at the time. So that's the kind of eventual consistency thing that you face with NoSQL solutions as opposed to these transactional solutions like VoltDB. And you'll also see there where Bazad talked about the ad hoc capability. And that was another thing that was mentioned yesterday during Nikita's presentation, where he said, you need to know the queries ahead of time for VoltDB. Not quite. You can do ad hoc queries against VoltDB all you want. If you want the really best performance, you put those into a stored procedure and we compile them and you get really fast performance, but you're welcome to do ad hoc queries as well. And so when I was putting this presentation together, coincidentally, I saw this article pop up, web article on Amazon Web Services and using Ignite to be able to put together a solution. And I started reading this and saying, okay, maybe this is a possible solution. And then I saw, well, it started building. And you have the application, and then you use DynamoDB, but wait, then you need Lambda, and then you need Kinesis Firehose, then you need S3 and Redshift, and I won't even list Zeppelin there because you're using that for taking a look at all the results. Oh, but then you need Spark and Spark Streaming, but wait, you can get rid of Spark and Spark Streaming, and you can use Ignite and KCL. And I looked at this and said, wow. And this is a very similar situation to a lot of what our customers are doing. We run into a lot of customers who are trying to stitch together transactional systems using Cassandra and Storm and Zookeeper and Kafka. And we work very well with Kafka, but we try to eliminate a lot of that other complexity. So we have basically two components, and VoltDB being that speed layer. And we interface with lots of the existing back-end systems, Teradata, Vertica, all the Hadoop vendors. And if you want to implement some other things as well, you can put it onto a Kafka bus and have it feed multiple systems. So that's the kind of simplicity that we're talking about. And we're able to replace multiple parts of open source components with basically two components and maybe a third if you want to have a Kafka bus being fed on. And there we go. And so I think I have 1 minute left. Great. So just to leave you with some little education, maybe something you can use today. The word of the day is idempotence. How many familiar with the word idempotence? Oh, all right. Well, I won't go over too well then. Okay. So idempotence, or idempotent being the adjective form, is used in mathematics and in computer science, and basically it means you apply a function and it has the same result being called multiple times as it does have being called one time. So in programming, you set x to 5. It doesn't matter how many times you call x equals 5. You end up with the same result. And if you, and that was my 1 minute. But come by to the booth, and we'll talk about why idempotency is important.